Hello, my lovely students. I missed you so much. Here are a couple of questions for practicing for tahsili, okay? The first question says, if n is a real number, then the counterexample for n squared greater than n is. Even if you don't know what's a counterexample, check which one of those is different, okay? Counterexample means it's going to prove that this is not right, or it does not satisfy this inequality. Okay, so the only right answer here, if you try them all of you, or if you observe quickly, the right answer would be 0 because 0 squared is never greater than 0. Number 2, in the opposite figure, ray AB bisects angle DAC. Then which of the following conclusions is not necessarily true? Okay, the first one says DAB is congruent to BAC. This is a must to be true, right? A and D are co-linear, means they lie on the same line, or they are beside each other on the same line, and this must be true. Angle BAC is a right angle. Must this be true? Why? It doesn't have to be true. Maybe it's a 45, 45, 30, 30, 50, 50, whatever. So without completing, definitely the answer is C. You have to be fast in solving these questions. The conjunction statement is only true when. This part I did not teach you guys, but you supposedly took in geometry, I think in chapter 1 or something. The conjunction is only true when all its components is true, or all its components are true. Question number 4, the opposite figure shows the number of students, as you can see, successfully passing each subject. So 20 successfully passing math, not actually 20 plus 46 are passing in the math. And for the chemistry, it's 12 passing chemistry plus the 46. 46 means they're passing math and chemistry. And these two did not pass any of the math or the chemistry. So the number of students who did not succeed in chemistry equals what? So definitely something outside this circle, right? 20, these 20 did not succeed in chemistry, and these two did not succeed in chemistry. So the answer is D. The conditional statement, if then. That's also chapter 1, I think, in geometry. The conditional statement, if then, consists of what? It consists of hypothesis and conclusion. The conditional statement P then Q is false if the answer for this one is C, because this is the hypothesis and this is the conclusion, and the conditional statement is false if the hypothesis is true and conclusion is false. That's also chapter 1 in the geometry. Question number 7. What is the contrapositive for the statement if x equals to 2, then x squared equals to 4? The contrapositive of a statement, what do we do in it? Take a look at the answers. In the contrapositive, we replace the hypothesis with the conclusion, and then we deny them both. So the answer should be D, where if x squared is not equal to 4, then definitely x is not equal to 2. This is contrapositive of a statement. Number 8. If the sum of the measures of two angles is 90 degrees, then the two angles are complementary. Which of the following statement is the converse of the previous conditional statement? That's also in the geometry. The answer for this one is D. When finding a reverse of conditional statement, we replace the hypothesis by the conclusion. So what did we do? We said if the two angles, this is the conclusion. If the two angles are complementary, then the sum of their measures is 90, and this is how we find the converse. We reverse the hypothesis and the conclusion. Number 9, the number pi is. Do you remember these? Do you remember the Venn diagram? The number pi is an irrational number because it's an endless decimal and it's a non-stopping decimal. So it's not irrational and it's not imaginary and it's not an integer. It's an irrational number, which is I. We abbreviate it as I. Here is the Venn diagram that I was talking about in question number 9. the Venn diagram of all real numbers or real numbers. The first baby inside here is n. It's for natural numbers, which are 1, 2, 3, and so on. They do not include 0. And then a mommy here, the whole number includes the natural numbers and more. What extra? It includes 0. And then comes the z and eats them all, and the z includes negative and 0 and 1, 2, 3. And then the biggest father over here is the q. Q is the rational numbers. They include z and w and n plus stopping or repeating decimals like 0.22, 1.2, anyways, any stopping decimal, like for example 2 over 3 is 0.66666, any repeating or stopping decimal over here, for example 4 over 5, that's 0.8, and so on. What about this I? Is it imaginary? No, it's not imaginary. It is irrational numbers. Irrational numbers are the set of numbers that cannot be placed as a rational number, as root of 2, root of 3, root of 5, and pi and e. Any number that will end up in a decimal that's non-stopping and non-repetitive. Okay? And what is this R? This R means real numbers. But Q is not Q, which is rational numbers. We do not abbreviate it as R. We abbreviate it as Q. So these questions, or this part, is about relations and functions. The first question says, in the opposite table, what is the relation between x and y? What do I do in this question? In this question, quickly substitute 1 in the equations. Maybe start with C. Don't always start with A and B. Start with C, for example. Substitute 1 and see which one will give you 5. If you substitute 1 over, going to equal to 5. Okay, let's substitute 2. Is the answer 8? So no, I substitute a couple of them quickly in your brain and see. Over here, let's see, for example, 1 times 3 is 3, 3 plus 2 is 5. Let's try another one, 6, 6 plus 2 is 8. So yes, the answer is D. If you have more time, try other numbers as well. But don't stop on trying one x and y only. Don't one coordinates only. Try 2 or 3 if you have time. Find the value of the function f of x equals 2x squared minus 8 at x equals to negative 1. Okay, when we substitute negative 1 over here, what will happen? It's going to be 2. 2 minus 8 is negative 6. So the answer is A. In this question, they want us to find f of 3. Okay, this is a piecewise function, and where shall I substitute the 3? In this function or this function or this function? First of all, this function its domain is from 0 inclusive until 2. It doesn't have 3, and this is only when x is equal to 2, and this is x greater than 2 and less than or equal to 5. So this function is the function that includes x equals to 3. Substitute the 3 in it. What will you get? Negative 2. Over here, you're going to substitute the 3. Negative 2, when you substitute the 3 over here, negative 2 times 3, you're going to get negative 6. Negative 6 plus 1 is going to give you negative 5. So the answer is C. Number 4, if g of x is equal to x squared, then which of the following equals to g of x plus 1? So substitute x plus 1. Remember in algebra we used to do that. Substitute x plus 1 in this function. What will you get? But remember, it's not going to end up in x squared plus 1 only. It's going to end up in x squared plus 2x plus 1. Be very careful with that. It has to end up in a trinomial, and this is the only trinomial there, by the way. Which of the following is always true? Number 5, the answer is B. Each function represents a relation. What about A? The function does not represent a relation. The function represents a relation. Each relation represents a function. No, some relations are not functions. And the relation isn't a function. Sometimes it is a function and sometimes it's not. This was chapter 1, I think, in pre-calculus book, and I think it's also in algebra 2. Each function represents a relation is the only one that is always true. Which of the following graph represents a function that has 3 real zeros? We also did that in algebra 2. Let's look at the graphs. Which one? This has 4, this has 3, this has 1 looks, or maybe 2 if it's intersecting here. This doesn't have any real zero, has imaginary zeros. So the answer is B. The curve of the function y equals 2x squared minus 5x plus 3 intersects the y-axis. Where is the y-intercept? This is what they're asking for. Remember, this is the y-intercept. When you replace x with zeros, you're going to get the y-intercept, or basically C, this number is the y-intercept, and if there's no number, then it is 0. So the answer is A. Question number 8, the function f of x equals 1 over x minus 3 plus 4 has a horizontal asymptote at what? First of all, we took this in algebra 2 in rational functions. A horizontal asymptote, my eye has to be quickly on C and D. Why? Because horizontal asymptote is y equals, right? And if I were you, I would take y equals to 4 because I'm seeing a 4 over here. And that's right. If this number is not there, then the horizontal asymptote is at y equals to 0. If this number is there, then the horizontal asymptote is equal to y equals to 4. If they ask me for the vertical asymptote would be x equals to 3 because I can never divide by 0. Be careful with that. Horizontal asymptote, now your choices is between two numbers only, or two choices only. Number 9 says, if g of x equals x minus 4, and here is f of x, then fog, remember, what does fog mean? Fog means f of g of x equals to what? So, f of g of x equals, what is g of x? Place g of x in every x of f of x. So f of x minus 4. What is f of x minus 4? Place it here. X minus 4 to the power of 2 plus 1. I would definitely go for D because I guess by breaking this, I'm going to get x squared. I'm going to get something that has x in it, and I'm going to get a number, right? Nobody's running after you. You don't have to distribute and get the answer correctly, because in this case I'm sure the answer is a trinomial and the others are all binomials. Anyways, this is going to give me x squared, remember the middle term, minus 8x plus 16 plus 1. So this is going to be the answer as we said. Number 10, g of 2 and f of 3, they gave you the values of a couple of functions. Then find the value of fog of 3. What does that mean? It means f of g of 3. So let's see f of g of 3. What is g of 3? G of 3 is 2. So f of 2. What is f of 2? Stepwise, quickly, f of 2 is equal to 3. And the answer is B. Now let's practice some questions about finding the domain. The first question says the domain of the function f of x equals x squared plus 8x minus 24. Without thinking, any polynomial functions are continuous. There are no x's that I will substitute in this function and will give me an error or an undefined function, right? Polynomials are continuous and their domain is all real numbers without any thinking, okay? Number 2, find the domain of the function y equals 2 plus x over x squared minus 7x. Yes, here there might be a problem in the domain. Why? Because some x's, if I substitute them in the denominator over here, will give me an undefined function. Why? Because we cannot divide by 0. Here, the x's that will cause for me a division by 0 will be excluded from the domain. So basically, I think something from A or C, right? These are the ones that have 0, and I think 0 over here, substituting 0 will give me 0 in the denominator. Observe the answers quickly, not going to the steps directly. From the answers, I think the answer is C directly. The domain is all real numbers except 0 and 7. The steps, anyways, you would take the denominator and set it equal to 0. Here I took greatest common factor and then I solved. So x cannot equal to 0 and x cannot equal to 7 because these two numbers are the numbers that will cause the denominator to equal to 0. So the answer is definitely C. Number 3, which of the following numbers does not belong to the domain of the function? Okay, maybe substitute quickly. This is the easiest way. If I substitute 3, I'm going to get negative under the root. And here the problem is that I can't have a negative under the root. I can have a 0 over here, but not a negative under the root. Substituting 2 will give me root of 0, no problem. Substituting 1, no problem. And 0, no problem. So I think the problem is the 3. The steps are take the number under the root and set it greater than or equal to 0 because as I said this is a numerator and there's no problem, root of 0 is 0. So we will include 0 and then solve it. You're going to end up in x. Remember when you want to multiply by a negative number to flip the inequality sign. So x is less than or equal to 2. So 2 is okay in the domain and 1 and 0. But 3 is not okay in the domain. Again, I'm repeating, you did not need to do all these steps. You needed to observe quickly, substitute quickly the one that does not make sense to be an x of this domain or of this function. And this is going to be your answer, which is A. Number 4, the domain of the function y equals root of x plus 1 is. What do you think is the answer? What do you want from this function? It's a radical function, and I don't want a negative under the root, right? So what should I do? Set x plus 1 greater than or equal to 0. This is what I want from this function, right? I don't want it to be less than 0. Or definitely by looking at the answers, I would go for any numbers greater than or equal to negative 1. So we write negative 1 closed towards infinity endless, and infinity always takes an open bracket. So the answer is D. Number 5. The domain of the function g of a equals 1 root of 1 plus a squared is what? What do you think? Any number, replacing any number over here, and it's an a squared, and I have 1 plus. Which numbers would I replace them and they would give me an error in this function? An error as in this function, a negative under the root. How will I get a negative under the root and it's a squared, right? So any number would fit in this function without any steps. I would go for B because if I replace negatives, they're going to turn into positive. If I replace 0, I'm going to get root of 1. If I replace positive numbers, there's no problem. And the answer is all real numbers. The domain of the function f of x equals 1 over root of x squared minus 9. Here, let's take the denominator and set it equal to 0. X squared minus 9 equals to 0. So x squared equals to 9 and x is equal to plus or minus 3. Now, remember when we used to draw a number line and think which numbers are fit? Numbers less than 3 or more than 3. Numbers less than 3 or more than, negative 3. Numbers less than negative 3 or more than negative 3. So here's negative 3 and 3, and I would pick a number to know the inequality signs of the answers. I picked a negative 4 as less than negative 3, and I picked a 0 as between negative 3 and 3, and 4. Now, substitute these numbers in the function and check which ones would give you error. What do I want to know? I want to know if the solutions are less than negative 3 or between negative 3 and 3 or more than 3. Replacing negative 4 in this function, there's no problem. It's going to give me 16 minus 9. There is no error. So I think less than negative 3, all the numbers are fine. Let's try the 0 over here. Replacing a 0 would give me an error because I'm going to get root of negative 9, and that's impossible. Replacing a 4 would give me again root of 16 minus 9, and there's no problem with that. That's a positive number. So what do you think, which answer is right? The answers that show less than negative 3 opened. Why is negative 3 opened? Because negative 3 itself would give me 0 in the denominator, and I cannot have a 0 over here because the radical is in the denominator. Unlike this question, the radical was in the numerator, and here the radical was in the numerator. But this one cannot equal to 0 and cannot be negative. Take care of that. So over here, -3 cannot be included, and 3 itself cannot be included because they give me a 0 in the denominator, and so the answer is B. The domain of the function. So let's try to find which x's from the answers are excluded. Definitely it's not A, and probably, yeah, x cannot equal to 3 because of the denominator. But watch out. There is a radical in the numerator. I cannot have a negative under a radical, right? And this is a numerator. So what? This and this are both right. Both of them are right. So the answer is D. According to the denominator, x cannot equal to 3. According to the numerator, x should be greater than or equal to 2. Here I can use equal because it's in the numerator. Here I cannot use equal because it's in the denominator. Number 8, which of the following represents the domain of the function h of x equals root of 2x minus 3 over x minus 5? Here I have two things to think about, observing the answers quickly. Okay, x cannot equal to 5, yeah, is right, because the denominator cannot equal to 0, but this is not the only solution again. I will have to think about this root or this radical function, 2x minus 3, it should be greater than or equal to 0. So definitely x is greater than or equal to 3 over 2. I have to bear this in mind, plus x cannot equal to 5. So the answer is C. The domain of the function g of x equals 3x plus 4. There's no problem over here. It's a polynomial over 5 minus x. But there is a problem over here that the denominator cannot equal to 0. Which number will make this equal to 0? If this number, let's check the choices. I think it should be one of those, r minus -5. R means all real numbers excluding -5, while R all real numbers excluding 5. Yes, it should be excluding 5 because 5 is the one that will cause a division by 0, so the answer is D. In this question, it says if f of x equals 5x plus 10 and g of x equals x minus 2, then the domain of f over g times g over f of x equals what? What do you think? Basically, g will be once in the denominator and f will be once in the denominator, right? So here, when g is in the denominator, x cannot equal to 2. And when f is in the denominator over here, also x cannot equal to -2. Why -2? Because this is what will cause the function to equal to 0. So what is the answer? The answer is A.